Okay, we're going to go through some free response questions. We're just going to jump right in. These should be similar to the things we did last week. So here it talks, you can pause the video to read it a little more thoroughly. This one, it's talking about the calorie intake of urban and rural schools. So if you read through that, there is some important information. It talks about it being per kilogram. Not sure why they use kilograms and not pounds, but per kilogram weight of the calories. But the bottom line is, if you're looking through this and you've forgotten what a split stem plot is, if this is 20 and then this is 6, that's 26. Over here, this one is 32, this is 30 on the other side. We can read all those values. So it says, write a few sentences comparing the daily caloric intake, so the daily calories, in the rural high school. So the daily caloric intake per kilogram for urban is skewed right. Now, you might not look at that and think it's skewed right. If you tilt it the wrong way, you're not going to get the idea. What you have to remember in terms of the skew, if we're looking at it, the tail, where's the tail going? The tail is going really to the upper numbers because this is 40 and 42. Those are the biggest number of calories consumed in there. So that is skewed right. For the rural, it is symmetric and uniform. Okay, now, if one of the distributions is skewed, you should use the median. If they're both symmetric, we can use the mean. So we don't have the mean. We'd have to add these up. But you're going to have to, at this point, figure out what is our median. So the median, you might want to put these in order. Maybe you want to put them in the calculator. That might be helpful. If you're going to find the IQR, that would be much more helpful. But here, coming from the bottom, let's first figure out for the urban, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 20 numbers. So I'm going to come up from the bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the 10th number from the bottom, and the 10th number from the bottom, we're looking between these two. Okay, and the 10th number from the bottom, we have, this is the 11th number. We're between 31 and 33. I'm making a video just for those of you that walked in case you're wondering. Okay, and we're between 31 and 32, or 31 and 33. So 32 is the median for the urban area. All right. For the other one, the rural, we have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 as well. So we'll come from the bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we're in between 40 and 42. So you average those numbers between 40 and 42. So 41 is the median for urban or for rural, and is higher. You want to get comparative language in there. We talked about that in the other section, but now we've compared the median. So in terms of the C, we've got the median, the center, and we've compared both of those. Now, if it were me and I have these numbers, I would find the range for the urban is 42 minus 26, which is 16. And the range for the rural is 51 minus 32, which is 19, and is more variable or more spread. We got the comparative language in there of more. No apparent outliers. Now, we could do an outlier formula, but on this type of problem, I wouldn't do that. We don't have any that are just separated. So go by look when you're looking at this. Now, do we have all of the things? We have a context point. We have center because we did median and we compared the center. We have unusual features, outlier we did. We have spread and we compared the spreads, more variable, and then we have shape. We have one that's skewed right, one that is symmetric. And one of the points I didn't go through on the other one that I did just mention, if one is symmetric and one is skewed, the median will always be affected. So you should always use, or the mean will always be affected, excuse me. You should always use median even if one is skewed. Let's say you're on the AP test and you have 7 distributions. 6 of them are symmetric and bell-shaped and one of them is skewed. You're going to use the median as the measure of center because in that distribution, its mean will be affected. If it's skewed right, it's pulled up. If it's skewed left, it's pulled down. So part B, is it reasonable to generalize the findings of this study to all rural and urban 9th grade students? No, this was one school from each. And the findings are only generalized to these 2 schools. Unless you take a random sample, okay, it's the same thing. If we're doing a study and we do an experiment and a drug is tested on rats, you can't apply it to humans, and that's one of the things that everyone always has to realize. Whoever you did the study on, to whatever small group, that's the only group you can generalize findings to. All right, researchers want to conduct a similar study. They're debating which of the 2 plans to use. So now you should carefully read these 2 plans. I'm going to go through these a little bit better. Plan 1, have each student in the study record all the food he consumed in one day. Then they compute the number of calories of food consumed per kilogram of body weight for each student for that day. Plan 2, have each student in the study record all the food he or she consumed over the same 7-day period. Then they would compute the average. Which one is better? Well, plan 2. An average will be a better comparison, taking into account any random fluctuations that could occur only on one day. For example, maybe on Sunday, people eat more in one area. That could be what we have happening, something like that. But averages are always going to be a better comparison. Okay, so now comparing this one. Now that's a great question 1. It is comparing. Notice we use the CUS. Here's another question 1, exploring 2 variable statistics. So this one is dealing with the FUDs. Researchers studying a pack of gray wolves in North America collect data on the length, X in meters, from nose to tip of tail, and the weight in kilograms of the wolves. The scatter plot of weight versus length revealed a relationship between the 2 variables, described it as positive, linear, and strong. Explain each of the following. What does positive mean? As length goes up, weight goes up. Negative, as X goes up, Y goes down. So that'd be describe a negative relationship. We're doing this in context. Linear, the best model for the data is a line. We could have the best model be a quadratic, a parabola. The best model could be a curve. We're usually dealing with linear. Okay, so we've got form, which is linear, and we've got direction. Okay, that's part of FUDs. Strong, there's the strength. The correlation between the 2 variables is high, likely above 0.75. Okay, all right. Now, it doesn't address any unusual features, but we've got form, direction, and strength. We don't have unusual features. All right, the next one. The data collected from the wolves created a least squares regression line of negative 16.46 plus 35.02. Interpret the slope. So the slope is the 35.02. Remember, you can always take the slope and put it over 1. One of the things, I remind students, it's always y over x. Back in Algebra 1, we did y2 minus y1 usually divided by x2 minus x1. I always said it's the yummies over the picnic table. You put your yummies on the picnic table. You don't put your X's on top because the picnic table squishes the yuckies. Then they become yuckies rather than yummies. Okay, so goofy thing to remember that, but it's always y over x. So one of the things you have to remember, what's x and y here? Well, y in our case, y was the weight. Okay, so the weight would go on top, and the x is the length of the wolves. I'll put LG length. I'll put length. There we go. Okay, so remember, this is a prediction. That hat on the y, we predict weight to go up 35.02 for every one more. Now I might have to look back. One more what is one more meter? Again, why we're using meters and not feet or something like that. Meter in length. But that is the slope. Now this is something I believe everybody should be able to do. Make sure you know how to interpret slope. I'm going to interpret the y-intercept. It's not part of the problem, but I think it's good. So remember, this wouldn't be part of the answer, but the y-intercept, if you put 0 in for x, if length equals 0, just look at the equation and what would happen. We predict weight to be negative 16.46. I suppose these are kilograms again. Yep. Kilograms. Okay. Now, this makes no sense as a weight of a wolf can't be negative. So if they do ask you to interpret the y-intercept, you remember it's simply putting 0 in for x, so then talk it through. But in both the x and the y-intercept, use the words we predict. All right, one wolf with a length of 1.4 meters. Now, they give you the 1.4 meters, so we should take this, and we should take our negative 16.46 plus 35.02 times 1.4. See what that is going to give us. I'm not sure I can do this, but I'm going to try this. Let's see if I can copy that into here, and I can. It should predict 32.56 kilograms. Now remember, E equals y minus y hat. You always subtract the mean. The mean is our prediction that came out of there because the line is the prediction. So it's y minus 32.56. And you're like, where did the negative come from? We predicted positive 32.56 because in the formula it's negative. But then you would solve this and you would add 32.56 to the negative 9.67. You get 22.89. Make sure I got those numbers right. 32.56, 9.67, 22.89. So y, if we solve it, so 22.89 kilograms is the actual weight. Now, you have to remember that residual formula. If you don't remember the residual formula, that isn't going to help you. I do think sometimes remembering this is y hat, the residual, it's 9 below. What we predicted is up here. Okay, so if you draw the picture of what a residual is, you're getting that this is 32.56 and the residual is 9.67 below. So you would just simply subtract that from the prediction. If you simply go minus the 9.67, you get right to that number. Sometimes the visual makes the residual make a lot more sense. All right, the third one, collecting data. Alzheimer's results in loss of cognitive ability with aging. These are results. It track. Now again, pause the video so you can read this a little more in detail. I'm trying to get the video done with some speed, so it's not taking you a whole lot of time to get through it because you can read on your own and pause it. All right. What are the explanatory and response variables? Okay, so it says it's a strong association between smoking and Alzheimer's. So the explanatory variable is smoking 2 packs or more. And the response variable is the rate of Alzheimer's. Is it an observational study or an experiment? We may need to go back to check that out. It says it's a study that tracked these men and women who some smoked, some didn't. They would have made the choice. So since they chose to smoke or not, it is an observational study. That would be enough. But you may go on to say experiments, subjects are assigned to treatments. So showing that understanding, that's good. It's not an experiment, so we can't determine cause effect. Now, exercise status, regularly weekly exercise versus no weekly exercise was mentioned in the article as a possible confounding variable. How could it be confounding in the study? Okay, well, people who smoke may be less likely to exercise, and those that don't may take care of their body and exercise more. So exercise could be reducing the rate of Alzheimer's. As a confounding variable. Sometimes we call it a lurking variable. Confounding, it means confusing. So the results are confused because it might be the smoking that's causing the Alzheimer's, but it might be the lack of exercise that's causing it, or rather the exercise that's preventing it. And that needs to be explained. Okay? So this question, I'm just going to do it. We really, since there's only one thing left, the seniors at 3 high schools were surveyed at their plans of graduation. One senior reading the question from the high school will be selected at random. What's the probability the senior selected will not be from high school B, given they responded with a choice other than college? Okay, so a choice other than college would be work, military, or undecided. Okay, so we'd have to get, first of all, we can't get these values in here. So it's out of these 3 groups. So a couple ways we could get it. We could add those 3 together, 244, 106, 188, or we could take 956 minus the 418. That's the only one out of there that we wouldn't need. So the bottom number we're drawing out of the 538 students potential. So it should be out of 538. I think our only option is going to end up being E because it's the only one that's drawing out of those groups. But then they will not be from high school B. Okay, so high school B would be these 3 values, and they got to not be that. So 62, 26, 54, we're going to add those up. That's 142. So they cannot be that. So we're going to subtract the 142 from that. Should be 396 out of 538. Once you get the bottom answer, that was the only one. Hopefully, those are making sense. I think all three of those open response questions, they're good examples. They're a couple of them are old number ones. A lot of times, number one is the FUDS or cuss question, if there is one of those in there. But this one was a little bit more on the some of the stuff we did at the end of the week. Anyway, hope that is helping. Thanks for watching.